Start recording. And this is going to be our session 8 of data science. And today we are going to talk about machine learning. I'm going to give you a flavor of what is machine learning and how the data science is important for machine learning. And we completed the quiz. Can you can you start recapping what we did last week?
Yeah, I'd like to recap what we did last week.
Yeah, go ahead.
I'm Kevin, and we did what we did last week was we investigated a new library called Matplotlib, and it was revolving around the functions of data visualization, all the way from graphs, different types of graphs, to showing data in tables and stuff. So what this is, this benefits because you can this is like the beginning of like this last session was the beginning of for us to see what we're doing. So before then everything was like theoretical and it was inside the computer, but then after we learned about Matplotlib, we were able to physically give a representation to that data, and like eventually, like you can see what's going on.
Yeah, well said, Kevin. Yeah, that's right. Yeah, nice one. So yeah, when you can look at the numbers all day long, but when you're starting to look into the data, like when you're seeing the picture, that will make more sense, right? A picture is worth 1,000 words. That's what the saying is go. So when you put the data in a picture and a graph, that is giving you more insights of the data. That's good. Yeah, good work. And today we are going to talk about machine learning. I want this session to be a little interactive, so I want everyone to unmute yourself and chime in whenever you want. You can either use your voice or you can use like chat function to interact. Okay, I wanted this to be interactive session. Okay, what comes to your mind when I throw the term machine learning?
I think of stuff like robots that can remember your name or
okay,
can tell you what a
good
is.
Okay, good work. Good, Jonathan. Next.
When I hear like machine learning, I think of, oh, sorry, someone talking?
Yeah, go ahead.
Okay. When I think of machine learning, I think of like using technology to learn about new things or find out things that we couldn't discover on our own. Like in the oceans, we can send down like technology to learn more about like different plants and animals or things like that. So we can use it to discover and learn more about our world.
Wow, good one. Yeah. May I know who's talking?
Yeah, Shravya.
Shravya, good Shravya. Please announce your names because I know few of your voices, but I'm not that familiar with everyone's voices. So when you're talking, please announce your name. That will be helpful. Okay, anyone?
Yeah, I'll go next. So when I think about machine learning, I think about giving an inanimate object the qualities of a human and bringing its intelligence, or bringing human intelligence further using like advanced methods like robots and like artificial brains and like expanding intelligence.
Good one, good one. And Eddie typed in machine vision for a self-driving car. That's a good one. So you're talking about all this stuff, right? Are you using machine learning, or like are you using any machine learning software, or are you using anything in real life now? Anything with machine learning, AI, or deep learning? Are you using anything right now?
Just computer, probably.
Just computer, okay. What else?
I have recently me and my friends have been working on a drone, and it
Okay.
has a bit of machine learning inside of it, as in like it like we don't have to like control its landing, and it's like it automatically lands on a place that's smooth, so it has to analyze the ground, and
Oh,
that's
okay.
yeah.
Good
So
one. Good
yeah.
one. So, okay, let me pose you a different question. Yeah, right, Eddie, that's what I'm coming here. So, you're using Siri, Alexa, Google, and you all use YouTube or Netflix or Amazon, like all these streaming services, music services, right? So, when you log in, what do you see in the login page?
I see, hey, what's your password? Hey, what's your username?
Okay, good. Then, after you log in with your password and username, what will happen?
Recommended
All of your
section.
like your video recommendation.
Video recommendation. How do they come up with the video recommendations?
Cookies.
Cookies. Okay, then everybody like cookies. Okay, so how they come up with recommendation is what they are doing is they are collecting the data, what you're looking into, what you're searching into. Then they analyze it and they're coming with recommendations.
It's a
Right.
logarithm, basically.
Logarithm. Yes, exactly. So that is what machine learning. So we use that everywhere. Like when you're going to your smartphone, and if you're going to log in with your Face ID, that is a deep learning or machine learning. We can say that one also because it is analyzing the image, your image, and it is confirming whether it is you. You may like dress differently, little you may have a different hairstyle, but what it is doing is it is going to analyze your image and it is going to tell, okay, you logged in. So we have the AI or the machine learning uh, applications everywhere. Whatever like we are going on right now, everybody is using smartphone, everybody is going for Netflix, or everybody is like a lot of people are using YouTube. So all your lives are touched by this. That's why I think this is a best time to learn about it. Okay, let me go here. So if you look at that, the concept of AI started early 1950s. It may be amazing. It started a long time ago, and it evolved. Now it is a buzzword. Your AI, machine learning, and deep learning is a buzzword. Do you know why it is getting more popularity now, even though the AI started in 1950s? Any reason?
I feel like the reason might be since machine learning is what's going to um it's like it's technically like more advanced than a human brain. Like you're making the human brain more advanced, so you're technically what you're doing is you're enhancing human capabilities. So
Mm-hmm.
anything that's and now that you can like now they have started like doing like a robotic body parts. I think machine learning would help in like just purely advancing a human body.
Yeah, that's a good way to say that. The other thing that made this possible, that's right, Eddie, because right now we are collecting the data. Now the data, they are collecting the data, they are storing the data, and we are having big data now. Lots and lots of data, lot of data points, and our computers are getting more powerful to analyze the data that we have. If you look at that in even in 1980s and 1990s, your computer will be really big, right? Really huge. But now you can use just a smartphone. That little phone will let you know like what you're doing with your whatever the phone you're using, it's like a little computer, right? So now the memory capacity increased, that we are collecting more data, and we have more capability of collecting data, and as Kevin put together, our human capabilities of analyzing it also kind of like we have more tools right now. We invented or we wrote more codes to analyze it. That is why it is getting more popular, even though it started in 1950s. And we are using this term, right? Artificial intelligence, machine learning, and deep learning. It is interchangeable. And let's talk about what are the differences, or what do you mean by those three. So if you look at that, so artificial intelligence is the broader concept. It is the broader one. And machine learning and deep learning are a subset of artificial intelligence. And deep learning is a subset of machine learning. So what we are going to do is we are going to talk about each and every concept in separate, and we are going to get some examples, or we are going to talk about what all three terms means. Okay, so and uh, you know about this, right? We can say all the squares are rectangle, but all the rectangles are not square, right? You know that, right? Something like that. The deep learning, all the deep learning, we can say it's a machine learning, but not all machine learning will come under deep learning. Okay, so let's move to the next one. We are going to talk about AI. So what we are going to do in AI, neural networks, yeah, we'll come back to that. Neural network will be part of your deep learning. We'll come to that. So now we are talking about AI. So what we are going to do is, with AI, we are going to make the computers, we are making computers intelligent, so they can act intelligently. This is the nice way to say artificial intelligence. Otherwise, we can say artificial intelligence is a technique that allows machines to act like humans. So like the self-driving car, what it is going to do is it is going to analyze the environment, and it is going to look for any possible hazard, and it is going to drive, like it is going to take decisions, right? It is based on the data available. It is going to take any decision, and it will implement the decision. So the decision making process will be done based on the experience that the machine has, the AI has. So this is what other definition. AI makes it possible for machines to learn from their experience. So we also learn from our experience, right? So when you started this class, whenever you're looking at the data, you may think about a different way. But after your experience, after your, like, whatever you have hands-on experience, your homeworks, you learn from that, right? And now how you look is little different from what you have looked in prior to this class, I can say that, right? So something like that. Yeah, some experience will give them to uh, uh, give the AI to think differently and act differently. And then we are going to, so what do you mean by intelligence? So intelligence, you need to know, like, what is the reasoning, and you need to learn from it, problem solving, perception, and linguistic intelligence. So you need all these in order to act intelligently. Okay, so the machine is going to reason out. It is going to tell, okay, if the car is going in a particular speed, and if there is a block in front of it, or the signal turns, it is going to reason it. Okay, we need to stop. We need to reduce the speed or stop, something like that. It is going to reason it, and then it is going to learn from the environment. It is going to learn. I hope you are all driving, right now. You may start learning driving, or you are in process of getting the driving license. Anyone can share your experience about that?
I haven't started driving yet.
You're not yet. Okay, then who has experience with the, like, have you had your learner's permit, or are you started to drive, or can you talk about it?
I have my learner's permit.
Okay.
So, like, wait, what do you want me to talk about?
No, like your experience when you start your driving, like, what, have you started driving yet, or not yet?
I have.
You have. Okay. Well, what's your experience with it? Like, What is your experience when you started first and now?
Well, at first it was extremely confusing because I didn't know what I was doing. But then like after that, I started learning from whatever mistakes I made and I got better.
Okay. So this learning is part of the intelligence piece. So now we are giving AI the same piece. We are telling the car to drive, and it is going to take that experience and it is going to learn from its experience and problem solving. So anything arises, it needs to we need to solve the problem, right? If any uh, anything unexpected comes, we need to solve it, and your perception and linguistic. So all these comprises of intelligence. Right now what we are doing is we are trying to give all these to the machines, and that's why the AI is not only part of your coding, and it's not only part of your programming. You need to have psychology, like you need to apply concepts from psychology. You need to apply concepts from your uh, from linguistic, because all these will help the uh, program or the code to run better. Okay, so we talked about AI. Now I think this is another definition, or another way to put AI together. It is just read it, and it is going to talk about how AI evolved so far, and how what is the difference between the AI and the normal programming. Just read it, and you will be able to get it. Okay, so this is all about AI, because the AI is the bigger concept, right? But AI comprises of deep learning and machine learning. So we just talked about AI, and we are going to machine learning. We are going to talk about machine learning. So machine learning, as I mentioned already, machine learning is a subset of artificial intelligence. It allows the machine to learn and make prediction based on the experience. The experience is the data here. So that is how the data science come into machine learning. Machine learning deals with a lot of data. And whatever you have learned so far is how to manipulate the data, how to analyze the data, how to visually present this data. So all this concept, whatever that you have learned with the data, will be applicable to the machine learning, because machine learning is based on data. So that is why the data science is getting more popular day by day, because the data science is really needed for your machine learning and AI tools. So that's about machine learning. And yeah, let's go here. Okay, so here I'm going to give you the difference between the machine learning and the regular learning. Remember when we start this class, you started with predicting with the regression analysis. You draw the regression graph and you predicted what is the gold price for this year. You were using the program, like not program, it's an Excel program to calculate that. Remember that? So that will be your traditional programming. You are having a data and you have a program, and there will be an output. So that is the traditional programming. Whereas now we have the machine learning. What we are going to do is we are going to input the data, and the data is going to be analyzed, and we are going to come up with some algorithm, and the algorithm is used to create an output, and we are also going to feed the output. So it is going to be a continuous process. So right now we talked about the Netflix and the YouTube recommendations, right? So when you are going to start with that, you're going to set your preferences. Okay, I like this genre. I like this. You will be setting up certain things. Then you will start watching certain movies or series, right? And based on your watch like whatever you have watched, the recommendations will change. They will, because they are going to take they will recommend something and you will watch, And that whatever you are watching, it is going to be again going to fed into the algorithm to come up with a new recommendation. So it is going to be a continuous process. So maybe when you start, you may not see whatever the series or your music that you like, but after using some time, you will also always see that you are getting all the recommendations. Anyone want to say something? I hear someone is. Do you want anyone want to say something? Any questions? Okay, so this is how there is a difference between the traditional programming and machine learning. So in traditional programming, you'll have a program and the data and you'll get the output, whereas you will feed the output to the machine learning and it will keep on evolving. It is going to be this is going to be evolving. It is always a continuous improvement in it. The algorithm will continuously learn from the data and it will improve it. Okay, so this is about the machine learning, and here I'm going to talk briefly about the types of machine learning. So the machine learning, we have like basically three big types. One is the supervised learning and the unsupervised learning, and we have the reinforcement learning. So the supervised learning is what we are going to do is we are going to give the data and we are going to say whether it is a good data or bad data. We are going to label it. And based on the label, it is going to use the regression or the classification approach, and it is going to come up with the solution, or it is going to come up with the output. So then the output will be fed again and it will be continuously evolving. So here what you're doing, yeah, go ahead.
What do you mean by good data and bad data?
So let's say you are all going for applying for colleges, right? I'm going to just take that as an example. Okay, so when you're applying for colleges, what are the outcomes you'll have?
Like getting into college or not getting into college?
Yes, so you have two outcomes, right? Getting to college or not getting into college. Sometimes you will be deferred also. For certain colleges, you will be deferred and they will then let you know whether you got in or not, right? So you have three possible outcomes when you are applying into the college. So what we will do is we are going to feed the computer, we are going to feed the data for whoever got into the college, whoever rejected into the college, and whoever deferred. So we are going to give all the data to them and with the outcome. So what the algorithm is going to do is it is going to check, so what are the factors they have for the students who got admitted? What are the factors they have that students got rejected? What are the factors that student has who got deferred? So what it is going to do is it is going to analyze and it is going to come up with certain like algorithm. It is going to come up with certain parameters. Okay, if the student has this much of GPA and this is the standardized test score and this how the goodest essay they will be get admitted. I'm just making it up because we never know about the college application process. A lot of black boxes there. I'm just making it up. Okay, so we will come up with the equation that will tell who will get admitted, who will not get admitted, who will defer. So here, what I mean here, good and bad data is, good data is what is the positive outcome, bad data is negative outcome. We are going to give and we are going to label it. Okay, we are going to tell these sets of students were admitted, these sets of students were not admitted. We are going to tell the machine, and it is going to look into various parameters and it is going to come up with the equation. So then what we will do is we will get the other set of data that will not have an outcome. So that what we call as test data and train data. So we will get just the parameters. We will not give the tool whether they are admitted or not admitted. So what we will do is we are going to analyze with the data and the machine will give you the program will give you the outcome, whether this set of students will be admitted or not. So it is going to give a prediction. So in order to get the prediction, we are going to give good and bad data. That means positive outcome and the negative outcome also. That is called supervised learning. And we are also giving the outcome in the data itself. While we are feeding the data, we are going to give the outcome itself. That is called supervised learning. Whereas the unsupervised learning, we are just going to give the data. That's it. We are not going to tell whether the student got admitted, rejected, or deferred. We are just going to give the data here in the unsupervised learning. And the algorithms is going to cluster or it is going to group the students based on certain criteria. And it is going to look for the visualization. We can, like, it can do the scatter diagram. It can do, like, a lot of things can be done. And here you will not get the outcome. You will not feed the outcome to the data. That is the difference between supervised and unsupervised. Supervised, you are going to, when you are feeding the data to analyze, you are going to give the outcome. Whereas unsupervised learning, you are not going to give the outcome, and the system is going to check, and it is going to compare each and every parameters, and it is going to come up with certain it is going to come up with certain item. So mostly, like right now, if you look into the Kaggle, we have a lot of supervised learning. I don't see like unsupervised learning, and I don't have an example for it now, but I have the example for the supervised learning. So that's the difference between the supervised and unsupervised learning. Any questions, or do you want me to elaborate it a little more?
For the unsupervised learning, does it still like give you some output? Or
yes, exactly, it is going to give you some output. It is going to give you some output. It is going to tell, okay, these are the parameters, those are closer, and these are the, like, these it is going to give you it is going to give you some output. And we are going to use a lot of algorithm, built-in algorithm for the unsupervised learning. And these are, if you look at that, these are the outcomes of it. If you look at that, we can go for the customer segmentation. Let's say we are going to feed the customer data, and what it is going to do is it is going to can you give me an example for some industry? I can talk about that for the customers based on that industry.
Call center, where you say one and they send you to a department.
Okay. So that is not I'm not sure that will fit here. I'm trying to get how we are segmenting the customers. That's what I'm trying to say. Okay, let's say you want to let's say you're launching a new product, and you want to know what, like, how to target your customers. You may need to let's say you're going to launch a new music video. I'm just coming up with that. You're going to launch a new music video. You're going to release your music video, and you want to target that to a particular group. So what you are going to do is you're going to take data from somewhere, what are the current existing trend, and you're going to analyze it and check what criteria that will be pleasing for certain target groups. And if you have that particular target group, you can use your music video to target that particular customer. So you will have some outcomes. I'm not that familiar with it, so I'm not able to get more examples on this one. But this one, I have more familiarity with the supervised learning. That's why I can talk a little more on this one. But these are the types of the machine learning. Or you can Google. I think I have something here. One moment. Give me a moment. Let's go here. So see, this is about the supervised and unsupervised learning. And I don't know whether we have any example exactly for the unsupervised learning. But you're having, these are the applications that we are having in the machine learning. So all the links I'm adding in the PowerPoint, you can look into later. I'm sorry, I'm not able to give more examples on the unsupervised learning. Let's go to the reinforcement learning. So reinforcement learning, what we are going to do is we are going to learn something. And what we are going to do is we are going to feed the data, and the data we are going to feed is going to analyzed, and it is going to used to change your change the features of the algorithm. And the great example is if you're playing against video games against the computer, what it will do, it will learn your moves and it will replicate your moves, and it is going to learn from you, and it is trying to beat you at each and every level, right? So this is reinforcement learning. So it is going to take the data from you, and it is going to use it, and it is going to enhance its algorithm. So this is about the reinforcement learning. And so I have my links here. Try to read it, and that will give you more information about it. Okay. Any questions? Okay, let's move to the next one. So here, this just as I was telling you, so what we need to do is when we are working with the machine learning, you're not going to use the whole data asset. Let's say when you have the data, you're going to split your data into your training data and testing data and validating data. So let's say you have like 100,000 records. Don't use the 100,000 records to train the data, because you need to save some data to test it. You need to know whether it is going to work, whether your algorithm is going to work. So what we are going to do is when you get the data, you're going to divide your data, like 80% you can use for your training data, and the remaining 20 you can use for validating and testing the data. And I will show you a quick example. Let's go to Kaggle, and I will show you a quick example here. I'm going to just go here, and it is going to this is the Women in Data Science Datathon. And here, if you go here, they will be providing your test data and the train data. The train data is the one you're going to train your model, and the test data is how you're going to test it. This is how I said, like, this is a supervised learning. I can say this is a supervised learning. What we are going to do is, we are here in the train data, you will have all the parameters. If you look at that, all the parameters are here, and here it will give the EMI also. I need to go. We have 64 columns. Yeah, so if you look at that, this is talking about a building, and it is asking you to calculate the site UI, that how much as building is going to consume energy. It is going to talk about it. So they have provided in the train set, they have provided all the data, and you're going to build your algorithm. Then after you build the algorithm, you're going to test it. Here, you will have only 63 columns. The one column is missing, the output column is missing. So here your job is going to find out what is your site UI, that is the outcome. So this is a supervised learning. So we are using 80% of data to train and 20% data to test. So let's go back here and here. So this is a supervised learning. So we are going to train the data. We are providing all the inputs, right? And it is going to learn from it. And from the learning, we are going to come up with the algorithm and we are going to test it in a sample set of data. So that is what, like, I'm talking about the training data, testing data, and validating data. Any questions on this one? I can talk about with the AP exam also. So you might have already done with your AP exams, or you are in the process of doing the AP exams, right? How it is going, your AP exams?
They're actually starting to just kick in since not even it's like not the fact that the AP exams are hard. It's just that when you have like other classes to study for, also like finals for other classes, like I'm taking like 2 college classes right now.
Okay.
So I have to study for those as well, and then I have to study for like 5 other different finals for school, and then I have to do like 2 AP exams. So it's just that like the amount of exams is just what is like hitting.
Overwhelming. Okay. Yeah, I get you. And apart from that, you have other activities also, right? Any volunteering activities or any other sports or anything else that will also take your time. So why I'm bringing the AP exam is your teacher, what they will do when they are going to train you for the AP exams. They will start giving you set of questions, right? And for your practicing, you will do the DBQs, MCQs, and everything you are doing for practice, you will do practice. And before your AP exam, what they will do is they will give you a full set of exams, or they will test you on a set of questions, right? So the same thing here. You are going to train your model with every day, or you're going to train your model, you're building your algorithm with your training data. And towards the end, when you're done with your training, you're going to use the testing data to test whether your algorithm is right or not. So that's why I want to bring that analogy of AP exams, how your teachers are training you for the AP exams. Okay. So this is how we are going to work on the data. Then let's go back here. So I want to talk more about the data because our class is more emphasizing on the data science. So I want you to be really comfortable when you're talking with data and when you're approaching the data. Okay. So here, what we are going to do is machine learning. We are going to train the data, validate and testing data. And here, these are the properties of the data. You have this, with the growing world population, you have more volume of data. We are getting big data every like the data is, and we are getting more data each and every millisecond. And variety, you have variety forms of data. It may be like your images or your x-rays or videos, audios, or it can be your data file. So you are getting structured or unstructured. You are having variety of data. And the velocity, the rate of data streaming is also a high now. And so this is about the properties of the data. So you need to understand the data, and based on the data, you will be using the analysis. Okay. So I want to know, can you talk about the data and data types? I think this is a good time to bring that in. Why we are concerned about data type? And what are the data types you know? Anyone want to answer? we saw the data types in prior lessons, like what are the types of data. You talked about your nominal, cordial, and you talked about your data types. Also, we can talk about like dates and numbers, integer, decimal, and string, list, tuple, dictionary. All these are the data types, right? The reason why we need to know the data types, whatever the underlying data types is, you need to know how you are going to store the data and what operations you can do with the data. Let's say if you have a string, let's go back to Kaggle here. I'm going to, okay. So if you look at that, this one, what is this? This year factor is a number. Okay, it's an integer. You can see it's an integer. So with the number, you can do operations like addition, subtraction, multiplication, division, whatever operations you can do. And if it is, if you look at that, this is a text. With the text, what you can do, you cannot multiply or divide the text, right? You can only, what you can do, you can aggregate it, or you can filter for it, you can sort for it, but you will not be able to do multiplication, division, or mod. Okay, so that's why you need to know what data types you are talking about. What based on the data types only, you will be able to determine whether what kind of operations you can do on the data. So that is really an important factor you need to know when you're analyzing the data. Okay, now, so when we are cleaning the data, because all the data is not it's not in the real world, you will not have a clean data, right? You need to do data wrangling, data cleansing before you use for the machine learning. So what we are going to do is, these are the things that you may need to work on while analyzing data. You may need to remove the unwanted observations. Let's say if there are any outliers. We talked about the outliers in the statistics, right? So anything with the outliers, you may need to remove it. You may need to fix any structural errors. That maybe, let's say the unit of measurements. You can measure the units in metric unit, or in the you can measure that in pounds or in kilograms, right? So you need to know what kind of units that is applicable for the data, underlying data. You need to know that in order to fix that, and any outliers you want to manage it, and anything missing, if the data is missing or anything not applicable, you need to fix it too. So these are the steps involving in the data cleaning process. This is where the data science is coming in for the machine learning. So you need to study your data, you need to clean the data in order to feed to the machine learning algorithms. Okay. Any questions on this one before I move to the next one? Okay, if you don't have anything, let's move. So examples of machine learning, I already told you the video streaming recommendations by YouTube or Netflix or Prime, or the product recommendations. When you're buying your products on Amazon, you usually get the product recommendations, right? So these are the examples of machine learning. And here I have a link and real world applications. I found this is really a cool thing to look. You have a lot of case studies. So if you, let me go for the Netflix case study. One moment. So this is about the Netflix case study, how they are using the machine learning in order to come up with the recommendation. Please read this one. This is really a cool one, and they talk about how they are approaching the machine learning in order to do the recommendation. Not only do the recommendations, they need to come up with their own series, right? So they need to know what customers like, what customers want to watch. So for that, they will be using this machine learning tool. Okay. And this one, the unexpected. Yeah, this is also a cool one. So we may not see the applications of machine learning here, but you can see this, like these are the unexpected users of machine learning. So this, I found this is really cool one. If you know ramen noodles, and if you're a fan of it, you can look into this. What this person is doing is he is using the image of the noodles, and he is trying to find where it came from, which store it came from. So this is about the image analysis, and this is about the music sound. You can create your own music. You can synthesize your own music, and with the program, and you can go here and check this algorithm, and how the algorithms are used to develop the music. And this one is application in the medicine. So for the diabetic persons, if they want to know how much insulin they need to take at a set of time, this ML program is going to give personalized recommendations and actions based on their sugar level. And this, they are using this TensorFlow. This TensorFlow is from Google, and they developed this algorithm, this TensorFlow. It's also a library in Python, compatible with Python. And this one, it is going to detect the sounds. Based on the sound, it is going to detect if there are any illegal activities happening in rainforest. I thought this is a cool applications of machine learning that that we can see in unexpected places. Okay. Any questions? Have you do you have any examples like that? Have you experienced anything like that? Are you using Alexa or Siri? Or any other speech recognition tools? You want to put it in chat? If you're using Alexa, it starts recognizing your voice and it starts responding to your commands, right? So that is the speech recognition. And we have the natural language processing also. That's part of the machine learning. That's also a cool applications of machine learning. And now we are going to talk about the deep learning. And Medha, I think you want to know about the neural networks, right? So this is the part of the deep learning. So the deep learning we use, so what the idea behind deep learning is, we are going to replicate the yes, okay, Sanjay, okay, matchmaking players in video games with similar levels. Yeah, that's a good one. Yeah, because you need to compete with a similar level, right? Yeah, that's a good application, good one. So let's come back to the deep learning. In deep learning, what we are trying to do is we are going to replicate how our brain works, how how we are adding weightage to each and everything. So we call it as the deep learning is inspired by the neural network in our brain, and the program we use in deep learning is the artificial neural network. And so whenever the data is getting bigger, we are going to add more neuron. That means more points of points, and it is going to it is going to learn from the neurons, and it is going to give you the outcome based on the mappings. Okay, so this is about the deep learning. Deep learning is a part of machine learning. Okay,
I have a question about that.
Yeah, go ahead.
So, how does it connect the data? Like, what does it use to do that?
So it is going to connect based on the weightage. Let's say we already talked about an example for the college applications, right? So it will give a weightage for each and every parameters. Based on the weightage, it is going to give. So then it is going to like I saw a cool diagram for the neural network, artificial neural network. What it is going to do is it is going to start from X, and it is like multiple factors in X, and it is going to assign weightage for each X. So that will be one neuron. Then what it is going to do is it is going to apply an algorithm, and you will get some outcome. Okay, and in that outcome, it is going to do some other combinations. Let's say I'm just making it up. Let's say the X factors are for the college applications are your standardized test, your essay scores, and your GPA. Let's start with the X. Then we are going to add more like what is the combination of it for like this kind of standardized test, like what is the combination of this and this. So each and every neural, each and every point will have a weightage. So it will go on until it find a y, optimal y, that is going to be the outcome. So how do I say this? Let's say if you are going to given a passage with spelling mistakes, will you be able to read it? You will be able to read it easily, right? Because your brain will act in a such a way. Okay, even if it is a jumbled, you will be able to make up the word because of your because you have your memory for that particular word. Something like that. We have the algorithms. All the algorithms are built in, and it is going to tell if you have this kind of parameters, it is going to be like this. We are going to come up with the examples. Maybe you may find it there. Okay, so we'll talk about the examples soon. So this is the basic idea is it is going to replicate your brain cells, like how your functions, how your brain cells function. It is going to replicate the same thing. Okay. Then I really this is the deep learning one with I'm not sure whether you know the game Go. So they used this with the deep learning. It is the Google's deep learning program. What it did is it beat a computer. It beat a computer, and it is all the strategy. Like for Go, you need to have a strategy, right? So it is going to replicate. It is going to replicate or it is going to learn from the human move, and it is going to take a decision. See, it is. And each and every time it is playing with an opponent, it is getting stronger and stronger because it is learning from the player's human. And the deep learning algorithm is used here. So go ahead and read about it. It may give you more information about the deep learning and what are the projects they have in deep learning. Okay. Oh, you learned about an AI class? Oh, good. So this is about deep learning, and we are going to talk about a simple example. Okay, so how do you recognize a square from other shapes? So you need to look at the properties of it, right? You need to check all the properties and make sure everything is there. And if everything is there, you will decide whether it is going to be a square or not. So this is a simple example just to tell you like how the deep learning will work. So let's start with so it needs to have 4 equal sides, and all the 4 sides need to be connected, and it needs to be like 2 sides needs to be perpendicular. So if all the properties are there, it is going to tell it is going to be a square. So it is just It is just replicating like how our brain works. Whenever we are looking to the object, we are analyzing the properties, right, in order to come up with what it is. So the same thing here, the same concepts apply here in the deep learning. Okay. Then one thing I want to talk about is a black box. We have a deep learning algorithms and neural networks. They are really complex. And even the computer scientists don't know what will happen, why that program made that decision. We don't know yet. We are still looking into it. We don't know that is called the black box. So you need to know about that too, because whenever we are going to use AI and deep learning and machine learning, you need to know what are the pitfalls in this program, or what are the challenges we have. So this is one of the challenges we have, and I have an article for you to share here. This is about the AI activity in the US intelligence agency. So they were talking about like the black box, and how we can how each and every program is going to evolve. And just read this one. This is really an interesting article. I want to share with you this one too. So you need to know the black box exists, and what does black box means. Okay, let's go to the next one. So here are the real world applications that I cannot talk about for the machine learning and deep learning. And we already talked about all of this, right? The self-driving cars. And in the email, when you're in the email, it is already like previously, all your spam will also come to your inbox, right? Right now, if you're using Google or Yahoo or any other email server provider, they are already filtering, and they are putting that in the spam folder, right? Even sometimes our math circle emails will land in spam because of their algorithms. And we also sometimes we advise people to look into their spam folder. And so that's like, it is there, but it is not that perfect. That's what I want to give this example. And you have like in healthcare, we are getting like it is the deep learning and the machine learning and AI is it is making more and more progress in addressing the healthcare issues. And right now with your phone, you whenever you're going to log, you're going to do your facial recognition, and Siri or Alexa, it's a speech recognition and object detection. When you're working on a self-driving car or any other robot, you need to know the object, right? And sentiment analysis, we'll be using the sentiment analysis when we're call center example. Jonathan was mentioning about the call center, right? So when we are working on the call center, when you're listening to the customers, you will be doing the natural language processing, NLP, and based on the words they were using, we will be able to understand the sentiment behind the customer's voice. So these are the great applications that we are having in ML and deep learning. Any questions on this one? Or do you want to add anything, any other applications that you have seen from the AL or AI or machine learning or deep learning? Okay, then so we are going to talk about we are talking about what is machine learning and deep learning, right? So what is the difference between machine learning and deep learning? So this is the difference between the so with the machine learning, we need human intervention. So we are going to take the data, we are going to feed into it, and we are going to come up with the algorithm. And if the algorithm is not right, we are going to make adjustments. Whereas in the deep learning, it is no human intervention is needed. It has its own neural network, and it will do, like, it is going to give you the predictions without any human interventions for the deep learning. Okay. And it is also the same thing, like whatever, like machine learning, you need algorithms, and it is going to parse the data, it is going to use the data. And yeah, I will come back to the codes and the files. And the deep learning, it is going to use the artificial neural network, and it is going to learn and make intelligent decision on its own. So that is the difference between the deep learning and the machine learning. Even like deep learning is more for the AI. Deep learning is it is powering the AI. That so machine learning, it needs a human intervention, right? So the deep learning is the way we are getting more advanced in AI. And how many Medha's question, how many files of code does it take to make these programs, or this code stored differently? If you're going to use a simple algorithm, I can show you that. The machine learning Cantal, let's go here. So let's go here. See, they have predicted this one. I'm going to just go for the top one. See, they have predicted this code. What they have used is, they have NumPy, Pandas, Matplotlib, Seaborn, and they are going to use, I think, Scikit learn probably here. They are using a different. So if you look at this is the code they have used for predicting the data. So this is the simple set of data. See, they are using train and test data. This is the code they have used. Right now, we have with the Python package, just with a simple set of 2 lines, you will be able to do wonders. So I don't, for the machine learning, you can use here Kaggle, you can create your code here. But if for the commercial, we have different packages. If you're like, let's say YouTube, they will have their own different packages, and they will have like their own servers and cloud. And I hope their program is going to be really big and complex based on the complexity of the nature of the business. So this is the simple one. See, this is how they analyze this is the they are using this package of Flam1 AutoML to do the machine learning here. And we can use the Scikit. There are a lot of packages for the machine learning. You can, when you go through each and every notebook here, you will be able to find this. Okay, so this is the first one, right? Let's go to the, see, they are using the PyTorch, and they are using linear regression. So look, when you're going through their data, you'll be able to find how they are going to train it, how they are doing the machine learning. And I will come to the course in the later part. And show you what you are going to do the machine learning part. Okay, let's go back here. And then, so we are talking about machine learning and deep learning, right? You also know the ethics. Like, can you define what is ethics, and what do you mean by ethics to you? When I give you the word ethics, what comes to your mind? Yeah, right or wrong? Yes, good. What else? We cannot take unfair advantage of anyone, right, with the machine learning or the AI. So even now, if you look at that, a lot of decisions that we are taking, is derived by ML. Even when you're going for Amazon, your cards will show the recommendations. Even you're not sure whether you need it or not, and we are not sure whether that the thing you want, but it is recommending, right? Sometimes you will just go by the recommendations, and the ML is making a life altering decisions for everyday life. So whenever we are programming, whenever we are using, you need to be really cautious. You need to make sure you're not violating anyone's right. You're not taking unfair advantage of anything. And as I already mentioned, there is a black box. When there is in the deep learning, there is a black box that we are not familiar with what's happening over there. So at the time, you need to make sure, like how you're going to how you're going to use it. You need to you need to have strong. You need to test it. You need to make sure it is right even before you implement it. Sometimes you may have unfamiliar scenarios. How you're going to react to it? And a lot of times you need common sense. And machines, we are feeding it, but they are not there yet, right? So you need to make sure we are going to have all this like we are getting all this like any ethical dilemma. You need to make sure you're not using it for wrong, or you're not going to use a MI or AI to the unfair advantage, to take unfair advantage of anyone. Okay, so that's what you need to always look for. Anytime when you're working, make sure you're not violating you're not violating any ethical codes. That is the one thing we always need to do. Okay, so the next one, I think, yeah, so we are going to, for this class, we will be talking about the codes, and we will be talking about how we are going to use this package. And yeah, we will talk about it. I think it is a good time to take a break. We will talk about the this all the models and scikit-learn after the break. Any questions before we take a break? Okay, if you don't have a question, we can meet at 10:55 a.m. PST. Okay. Are you all back? Shall we start? Are you able to see my screen? I'm sharing my screen. Okay, let's start. So we talked about machine learning, deep learning, and AI. Now we are going to talk about the package, like just one package. There are multiple programs available for this, but I'm going to just talk about one package that is going to be helpful for the machine learning. And the scikit-learn, this is the tool, like it is a combination of SciPy and Toolkit. That's why it's called a scikit-learn. And we are going to talk about it, and I'm going to show you what are the various ways that we can use this program to do the machine learning. There are built-in algorithms, lot of built-in algorithms, like whatever we have seen here, this slide. See, all these items are already built in, and we can use it by just calling few lines of code. So that is about the scikit-learn, the scikit-learn package, and it is going to give you range of supervised and unsupervised learning algorithms. Okay, let's go here. So if you look at that, like Matplotlib and Pandas and Python, like we have a community for this scikit-learn, and you have documentations. You can have all the documentations, and this documentation is going to give you what are the available methods. See, if you look at that for supervised learning, these are the methods available, and for the unsupervised learning, we have this kind of the um, package available. So you can use anything to based on your needs. So if you look at that, this is going to be the simple linear model, like we already talked about it, right? Like in our statistics, we built in the scatter plot, and we are using the regression lines. So you can do the regression lines with this just a few line of code. See, if you look at that, it is going to fit this one. You can see this one, right? So we have, as I mentioned, we have the package for supervised and unsupervised and other models also. So you can go here and look check any let's say if you want to know if you want to apply any of these features, you can go ahead and use this one. Okay, so these are the available algorithms. So when you're as usual, what you're going to do is you're going to start with importing. You're going to import the sklearn, and in sklearn you need to import what model you need. So these are the models, right? These are the models. So when you're going to import, you're going to import the sklearn, and you're going to import the model. Let me give you this while I'm here. I'm going to put this in chat. If you want, you can go ahead and check it now. And when after you call the model, you're going to pass the values. Okay, you're going to pass the values, and you're going to tell what you need to do. Then it's going to estimate based on the model you are suggesting. Okay, and you can also you can also plot it. There are various ways you can do it. You can explore it. Okay, and so these are the models that are available. So these are the like a by group. You have a clustering, you have cross validation data set. So these are the various models, and all the models are here. See, I think this is the other one. Let's go here. One moment. So all the models, see, these are the group of models like supervised and unsupervised. See, this is what I have it here. Okay. Then, so as I mentioned, you need to have a training data set and the testing data set. And using the training data set, you're going to use the model to train. And once you're done with that, you're going to use the other set for the testing. The same analogy I use for AP, you're going to train in your class with the set of questions your teachers are going to provide you. You will be getting trained on it. And on the test day, you will get a different set of questions, right? And the different set of questions, you're going to answer it. Same analogy here, you're going to train your model with your training data set. And for testing, you will have a different set of data set that is called the testing set. And then using the testing data set, you're going to check whether whatever the model you trained is valid or not valid, whether the outcome that predicts using the algorithm is correct or not. So if it is not correct, you will be going back to your training data set, and you will be adjusting your algorithm to make sure it is working optimally. Okay. Then this is the samples. If you want to know, I just have the samples like for this scikit-learn. I don't have my own code. I just want to tell you the samples that they already have. And this one, they are using the linear regression. So if you look at that, this is the data set. And what they have done here is they are just importing the libraries, and they are importing the data like using the panda read CSV function. They are reading it. And what they are going to do is they are going to, this is all the graphing, right? Okay, this is the, yeah, we already talked about the location, right, in pandas. So this is from, they are going to split the data. See, if you look at that, they are going to use the they are going to use the sklearn model selection, and they are going to import the train test split. What they are going to do is they are splitting the data. They are going to split the data for training and testing. Okay. Then what they are going to do is they are here, see, they are importing this linear model and linear regression. And they are going to find for a certain set of X, what is your Y. So you have your input, what will be your output. So and they are going to predict it. Based on the prediction, they are going to check whether prediction is right or not. So I'm not going to go over the code today. I just want to show you the code. So this is the page. I have the code. The code is there, so you can use this. And the other set of code I want to show you is in the Kaggle. In the Kaggle, this code, what they are doing is they are using, this is a cool one. They are finding how to, like outliers. What are the outliers? They are finding the outliers using this code. This is another package that you can use for the machine learning. And see, sklearn, and they are using the isolation forest. This is the package they are using. So isolation package, let me show you here. So it needs to be here in decision tree, or it needs to be somewhere here. Let's find it. Isolation forest. See, isolation forest. So this isolation forest, they use, see, in the Kaggle, they use the isolation forest in order to find the outliers. Okay. So there are various models for this. You need to know the statistics too. That's why I started with statistics, but that's just the introduction. You need to know statistics, and you need to know what are the tools you're going to implement to the for finding the for analyzing the data. Okay. Then, and I saw this book. This is going to be a good one. This is by Kano, and this one is really a good one for the data science. If you want, go over there, and it talks in detail. The reason why I'm giving all these resources is this is going to be our last class, right? This is going to be our last class, and next class will be our finals. I want you to continue in this data analysis. This is not going to be the end of this data analysis journey for you. I want you to continue it. I want you to work on like how we can, how you can improve your data analysis. Is just you have a lot of resources here. Just go there and check all the resources available, and talk. This is a really a good book. So read this one and use this wherever you like, however you seem it's fit. Okay. So I want to share this. Okay, let's go back. And okay, so what's next? Like what do you want to do after this class? Do you want to explore more, or do you want to explore other items? Do you want to dig deeper in the Python coding? If you want to dig deeper, the first thing I want to say is the Kaggle competitions. you can go ahead and you can submit any of the competitions there. Right now, you know basics of Python, you know basics of data analysis and data science, and take these, whatever you learned from this class, and apply here. Okay, so in Kaggle, let's go back to Kaggle again. So if you go to competitions, there are various competitions, and there are some prize money also. And you can, if you want, you can work in a team or you can work alone. Okay, and choose the field that really that you like. Let's say if you want to explore in games, you can just explore the data set in games, right? If you're really into the games, any games, see, this is for the football, and this is data see, poker. We have a lot of chess. So any games, if you're interested in any of the games, look for the data set in that particular area. Or if you're interested in music, let's say you're interested in music, how you can explore your interest, like whatever that interest you have, like how you can like how you can explore more. So this is a but it is already done, but you can go ahead and explore their code. This is the WSDM K-Box Music Recommendation Challenge. If you look at that, you can go to the code and you can look how they code, like how they approach the problem. What is their recommendation? See, random forest, I was talking about the random forest, right? See, they were using random forest to predict the data. So you can go ahead and look into it. One little caution I want you to pay attention is, go for the latest one. See, this is 7 days ago. If you want, you can go for this, like the latest one. Don't go for the older one. Let's say this is 4 years, 5 years, because we are getting new codes, like the package is updated every time. And sometimes the code will be depreciated. Like I said, when we are looking for the in NumPy or pandas, we have iloc and lock and iloc, but we don't have the xlock, right? That was depreciated. So the codes will be most of, like, it is evolving. So I want you to go ahead and look for the latest one, so you will be able to see the latest code. Okay, that is the only caution I want to tell you here. So that is the first option, to explore more. And the next one is developers Google. See here, like in Google has a Python class, and they have all the, if you want, you can go for a certification course. If you want, you can do that. And you can get, you have more opportunity to explore more. And this one, you may already know about Coursera. Coursera also has some courses for your AI and data science. Look for it, whatever you want to do, like try to attend few courses and get more exposure. And not just learning will help you to understand the process. Do hands-on projects. Come up with a project that you can work on during the summer, and work on it and publish the code in Kaggle. That's why I introduced to Kaggle, because you can publish your code, and the code will be public, and you can do discussion based on your code. You can have some conversation and you can learn from others. So Kaggle is a great place to learn data science. Okay. So these are the items I want to suggest for you to work on. Okay, I think that's it for now. Then we can go for the finals. So as I mentioned, we are going to have our finals on May 21st, right? And May 21st, same time, 9:30 to 12:30, you're going to work on your finals. And It is going to be multiple choice questions only, and it may be you may get definitions, code snippets, or you may need to do calculations, and you may need to use Excel, Google Sheet, or Python code. Okay, it is starting from the statistics. We will be starting for the finals. You will have the statistics. You'll have pandas library like the NumPy, pandas, matplotlib, and a few questions from the machine learning, whatever we did today. Few questions you may expect some. Okay. So, any questions on the final? It is on May 21st. Okay, and as you know, we will be awarding the top 3 from the final. Like we'll be providing like whoever got the highest score in the finals, we'll be giving prizes, and 2 other I'm going to choose based on your homework, your quiz score, and class participation. And you're supposed to be here to take the finals. If you're not taking the finals on 21st, you will not be considered for the prize. Okay, so if you want to consider yourself for the competition, you just make sure you're available on 21st and complete that final exam. And then I want to also talk about the triangular talk that is coming up. One moment, let's go to that. So the next one we are going to get is the triangular talk. So the next week we are going to have a triangular talk session, and that is going to be by a professor from Duke. See, so let me set a way to get this one bigger. So he's a professor from mathematics, Duke University, and he is going to talk about the algorithms. I think this is a good time for you because I just introduced to the algorithms, right? So he is going to talk about like how the modern computers and mathematics is going to solve the problem. I think this will be really apt for everyone who wants to explore the options in the data science. And this is a great way to connect the professor. So once you like if you want to work with him, or like it is an opportunity for everyone, right? If you want to work with any industry person or any professors, you can do a cold call. Like you can send an email, you can contact them. Okay, I'm such and such, and I want to work with you on such and such. You can do a cold call, or you can do like you can attend their events or seminar, get introduce yourself, you can talk to them, and you can later do a follow-up email and ask them, oh, I met you there, can I work with you, can you give me an opportunity to work on this project? So this is the way you can approach. I hope you like this is going to be a great opportunity for everyone to talk with this professor. Okay, then let's go back here, and for the last week homework, I see Eddie, Parnil, and Varsha. You did a great job in the homework. But I think you're still missing, like all of you are missing certain items. Let me talk that one because I want to explore that. And if you want to revisit your homework and do that, that's okay. One moment. Not the quiz. Oh, I need this homework. Okay. Give me a moment. It's opening. Okay. So you all did this, get unique values, and you were able to get a group by year, month, and average price. You were able to do that. I was not like, nobody answered this question correct. Like, you're supposed to get the date. Like, I have seen you submitted the highest and the lowest value, but I don't see the date. That is the one thing missing. You can go ahead and check back and go back to your code, revisit your code. You have the lowest volume and highest volume, but what is the date on the lowest volume and highest volume? And what happened on that particular day? If something happened, you need to Google it. Like, let's say it happened on I'm just going to come up with a number. So let's say it happened on November of last year on 7th. So you need to know what happened on 7th. You need to go to Google and check what happened to the Tesla share. Was there something happened to spike the volume or decrease the volume? So that is what I need for that question. But I don't see anyone answered for that question. Okay, is it clear now, like what I was expecting on that particular this one? So yeah, good work on this one. And I have a homework for this week. I'm going to show you that. Okay, so what I want you to do is I want you to go to Kaggle and complete this machine learning course. Like what you did for pandas, do that same thing for the machine learning course. They have the introduction course, they have the advanced course. Whatever you want to do, you can do it, but I'll just start with that introduction course. If you look at this intro to machine learning, so this course will help you, and this is where you're going to learn about your models and how you are going to build your models and what are the algorithms that are already. See, if I'm going to go here, it is going to talk about the random forest, and we are going to look the random forest just by, we are just calling that, we are going to call it, and how you are going to apply this in your model. So complete this course and send me the screenshot of the completion. This is going to be really a handy one, a hands-on experience. Once you have this, you can go ahead and do the other course, the feature engineering. This is also really a good one. This one is going to talk about more of your like how you are going to do the machine learning, and how you are coming with the learning, the supervised learning and unsupervised learning. This is talking about the k-means and how you're going to fit your model. Okay, so complete these, like first start with your basic course, this machine learning, introduction to machine learning, then go for the feature learning. And once you're done with that, you can go for the intermediate. And this is the way you are going to explore more. See, this has course for deep learning and time series, data cleaning, AI. There are various courses you have. Try, and if you're into the game, look for the game AI and reinforcement learning. So here we talked about the supervised learning, unsupervised, and reinforcement, right? See this. All these things are available, and you can go ahead and check it in Kaggle. See, all the courses are available. So during the summer, if you want to take a stab at it, take it, and it will give you more opportunity to work in data science. Any questions on this one? So we talked about the final exam, we talked about the quiz, and I talked about what are the other things you may need to do. And other thing I want to ask is, for the next semester in August, if anyone wants to teach the class, do you want to volunteer for teaching Python and data science? If you're interested in teaching data science and Python, please shoot me an email, or you can at support@agro.math circle, or you can send me a message in the message center. And if you're interested in doing any projects for data science, let me know. We can explore on that too. Or any competition in Kaggle if you want to do. If you need more help on that, please feel free to reach out to me. Okay?
I have a question.
Yes.
So does that mean that this class is like completely over after the final?
Yes. I'm not sure that whether we will have another session to go over on the data science, like more into the data science and machine learning. We are not sure. We are exploring other opportunity. I want to continue you to learn the other areas, how to use other packages and how to come up with any other. The main thing is I want you to go for any Kaggle competitions. I want you to submit for the Kaggle competitions. If we can have one more class, like maybe next year, if you want to do, that may be a possibility. But for the currently, we are just going to do the same thing again. We are going to do the Python for the first semester and the data science for the next semester. That is going to be the current plan for now. We may open up another class for whoever who completed this one. We may open up other class, but we are not sure yet.
Okay.
It depends on like how many volunteers we have, how many people, we need volunteers to teach, right? And so we are not sure how we are going to proceed. But for sure, we'll have the same class repeated next time, like a Python for the first one and the data science for the second semester. So we'll have the same class. If you want to retake and enhance, reinforce your learning, you are welcome to do that. Or if you want to volunteer for teaching that class, we always welcome volunteers to do that.
Also for the
yeah, go ahead.
Also for the Agra Math Circle final, will it be like calculators allowed or no?
Can you repeat your question, Jonathan? You're breaking up.
Math Circle final, will we be allowed to use a calculator?
Oh, Math Circle final, that one, I think it depends on the teachers and the questions.
Yeah,
because
in yet.
You have log, probably you can ask your teachers during the Math Circle, like afternoon you go to the Math Circle, right? You can talk to your teacher and ask whether they are going to allow you to use the calculator or not. Okay. You can ask them. And I see one more message here in the chat. We are not going to give any certificates because we are not this is we are not giving any certificates for completion on this one. Okay, this is just we want you to give you a flavor of what is data science and what is Python. The reason why we are doing it is we want you to explore this area. We are encouraging you to explore this area. And if you like it, when you're going to college, it will be like you can excel in this one. That's the main motivation behind this course. We are not providing any certificates. Any other questions or any other feedback you want to talk? You want to give any other feedback? You may think this may be a little better. That will be really helpful to you. What kind of, if you have any feedback, please let me know. Any other questions you have? And if you don't have any questions, I think we can wrap the class up. And I appreciate all your hard work, and I wish you all the best for the future. And we will see you in the finals. And I forgot to mention, I'm going to give 2 more awards. Like 3 will be the top performance, and 2 will be for the whoever did well in the homework and the class. It's based on your classwork and the homework score and the quiz score. Okay, and all the best. And the finals is 21st, May 21st. At the same time, you will be starting at 9:30, and we'll be opening the like same thing like this session. We'll be using this Zoom session. We'll be opening, and you need to log in. No, there is no class on 14th. 14th, you have a triangular talk. See, as I mentioned earlier, we have a triangular talk on 14th. Please attend this. It is from 9 a.m. to 10 a.m. PST, and it is by the professor from Duke, and he is going to talk about the algorithms. So I think that will be really a great one for you all guys to learn about the algorithms, how math and computer science are going to solve the real world problems. And this is the opportunity to talk with the professor. So please attend on May 14th. So May 14th, we have this triangular talk, and May 21st, we have the finals. Okay. Any questions on finals or your homework or anything else you want to address now? Okay, if you don't have any questions, I think we can wrap up and have a good day. All the best. Thank you.
Thank you. Bye.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramastercode.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email, but without the info and the end. So bye!